All right, fellas, we got momentum right now. Pretty brutal topic, if I must be honest, but let's get through it. Now, momentum has this formula which you have to memorize, and it's one of the only things in physics where if they ask you to define momentum, there is no sentence structure answer to it. You have to give the formula in full. You cannot use symbols, you have to give the formula. So you mentioned that momentum is equal to mass times velocity. You get full marks for it, yeah? There's nothing more to it. So just to give you guys some context, I'm pretty sure most of you guys saw the rugby tackle video which I showed you. And that pretty much shows you that if you have a lot of mass, you're very massive, muscular, and you can run very fast, you do a lot of damage, right? So momentum is just how much damage you can do to someone when you literally collide with them. The more mass you have and the faster you can move, the more momentum you have based on this equation. The units for it, if we look at it, units for mass is kg, units for velocity is what meters per second. So because we're multiplying them, you also multiply your units together. So just stick them together so you get this. So this is the units for momentum. If you forget it, just remember these two units and stick them together. All right. Now, conservation of momentum comes up every single year, every single paper. There's no escape. It's quite simple. All we're saying is momentum before an incident is equal to momentum after an incident, provided that you have two or more objects, which I'll explain now. Yeah. So you just have to memorize this, but I'll put it into context. Suppose you have a guy stationary, not moving, with a gun, which is also stationary, and basically he's going to fire it after some time. So let's look at it in the beginning. Remember, momentum is what? Mass times velocity or speed, right? So if you have your man here, 100 kg, he is stationary here, so his speed is 0. The bullet here as well is speed of 0 because you haven't fired it yet, right? So logically speaking, guys, if your velocity is 0, without even doing any calculation, your momentum also has to be 0, right? Because you can have the biggest mass in the world, you can be this many kg. If your speed or velocity is 0, anything times 0 gives you 0 as well. So momentum is 0. So all we're trying to say here is momentum of this guy is 0, momentum of the bullet inside the rifle is 0 because nothing is moving. So if your total momentum of the system is 0 in the beginning, your total momentum after you fire the bullet has to also be 0. And by that, what we mean is when you fire the bullet, just to give you some context, I've given you the mass, which is 1 kg, and I said the speed of the bullet is 1000. So using the formula of mass times velocity, or mass times speed, you get 1 times 1000, which gives you 1000 kg meters per second momentum this way of the bullet. Now, if we said that this has to all be 0 together, the only thing that can cancel 1000 this way is 1000 in the opposite way, because 1000 minus 1000 gives you 0. So all we need to say is in the question, momentum of the bullet is 1000 kg meters per second this way. Therefore, the man has to recoil this way with a momentum of also 1000 kg meters per second. The plus and minus just indicate that, and you don't have to include this, but just to have some logic, is that we just say this side's usually positive if you want it to be, this side's negative. So if you have positive 1000, negative 1000, they cancel each other out and you just get 0. Yeah? So I do hope that makes sense. Once again, the formula, guys, you have to know this, so make sure you copy it down. Let's now go through a few questions together. I always underline things, or actually I look at the two, because they always give you two different objects in, harder questions. So we have a car, and we have what do I make? I could have made it a truck, whatever. So let's say car A, right? So we got car A. I want to take down all the info of car A, and then I want to take down all the info of car B. So car A has a mass of 1000 kgs, right? What's the speed? It tells you the speed is, or velocity is. Don't fret if they tell you speed instead of velocity, right? They just have a bad habit of doing that, so I'm just, doing the same. Okay, now it says it collides with a stationary car B of mass 500. Stationary means your speed is what? 0, because you're not moving. And let's see. The mass of car B is 500. Okay, what we can do straight right off the bat, let's find the momentum of both cars, right? Momentum of this car is mass times velocity, which is what? 1000 times 5. Because your mass times velocity gives you 5000. So this is just the beginning scenario for both. Momentum of this we just know is 0 because your speed is 0. Momentum has to be 0. So this gives you 0 without any calculation. if you now you because there's two different objects, and basically one car is moving like this and colliding with another stationary car, we take them away from each other. So you just get 5,000 minus 0, which gives you 5,000, right? So your overall momentum, your total momentum of both cars in the beginning is 5,000. So when they collide with each other, so when car A smashes into car B, so this car A, car B, they both will move this way, right? Because car A is already moving like this. So it'll hit this car, then they both roll together like this. So they want basically the combined speed when they both move together. Now, if we look at the formula for momentum, momentum is equal to mass times velocity. What's the combined momentum of both cars together? 5,000. What's the combined mass of both cars together? Because when you want combined speed, you need combined momentum and combined mass. So we found combined momentum there. Combined mass, you just add the mass of both cars because they're moving as one body together. So 1,000 plus 500, that gives you 1,500. And you're looking for V. So V is just basically this divided by that now. Yeah, so we do this. And you get a number which I have no idea, maybe 3.33, I'm just guessing, but you get something like that, yeah? So that's how you solve this question. If it does not make sense, let's do another one because... Or actually, pause the video, try this, and then watch me solve it. Yeah, that's probably better. Okay, so you have a bus, once again, and you have a truck. All right, that's good. You got two very different things. Now, once again, take down all the information. Mass of the bus is what? 2,000. If you put your working out like this, it's very hard to go wrong. Mass of the truck is 1,200. And notice I'm putting all the units all the time. Initial speed of the bus is 10. And it doesn't tell you the speed of the truck, does it? Ah, but it does tell you, keyword, stationary truck. So stationary means that 0. You always want to look for those keywords, rest or stationary. So what's the first step we do, guys? We want the combined momentum, right? So find momentum of this minus momentum of that. So momentum is equal to mass times velocity is 2,000 times 10, which gives you 20,000. Remember units all the time. So we have this. Momentum of this we know is 0, right? Because if your speed is 0, there's no point even calculating it. Because 1,200 times 0 is 0. Yeah. So whether you add or subtract, you can subtract both of them, you still get the same answer, but we'll just do it just for principle. So you get 20,000 kg meters per second. That's your combined momentum of both things together. Now when they both collide with each other, so when your bus and your truck, so B for bus, T for truck, collide together, they move this way. Let's assume the bus was going this way. You don't have to draw stuff. I just draw it just to make life easy. So they both move this way, and we got combined momentum. Now we need combined mass. We add the mass of both things since they're moving together, which is what, 3,200. So combined mass, and these are the hardest questions they can give you for momentum, 3,200, because both objects move together. It's like, just to give you some context, you have, this represents your truck, this is your bus. Your bus was moving, collides with a truck, they both move together as one body, but obviously they move slower. Yeah, that's all we're talking about. So 3,200 combined mass, what's your combined momentum? 20,000. Sorry for dragging the video out, but this is the hardest topic, so I have to. So combined velocity is basically your combined momentum divided by combined mass. And that gives you an answer. I don't know, 5.8, I'm just guessing. I'm not sure. But you guys can put it in the calculator and you get an answer, yeah? So ignore that number, I just made it up. But that's how you solve momentum questions. Last but not least, they give you scenarios where you have to talk about conservation of momentum. Let's imagine you have like a guy on a boat, and you have the dock where boats like stop and the guy jumps off onto, a long path, right? Now, in the beginning, the boat and the person are stationary. So the total momentum of everything is what? 0, because no one is moving. The boat's not moving, the person's not moving. So when the person jumps off the boat, what happens to the boat? The boat moves backwards, right? Because if your total momentum to begin with is 0, your total momentum after also has to be 0. So what that means is if the man, hypothetically, let's just say moves up with 5,000 kg meters per second of momentum this way, the boat will also move with how much? 5,000 kg meters per second that way. Similar to the bullet question, yeah? Because they might ask you to link it. And if you want to link it to one of Newton's laws, you mentioned that is Newton's third law. For every action, which the guy's moving this way, you have an equal but opposite reaction that way. All right.